So regression, and again, all I'm doing at this point, you guys are getting like regression 101, like baby regression. Right? There are entire regression courses that you can take. So I'm giving you just enough to be dangerous. Okay? So a quick review of kind of some of the key things that we talked about last time. Remember, we're trying to predict a dependent variable using our independent explanatory predictor variable. We have a model equation, and we have our estimated regression equation. So we're going to be trying to create these estimated regression equations. We can make some predictions, do some explanation with our models. I just thought that one was funny. So we were talking about correlation and regression. Because I trust linear regressions when it's harder to guess the direction of the correlation with the scatter plot than it is to find new constellations on it. So no correlation here. So kind of we saw that in real life, right, with the AMP data earlier. So again, our focus is on interpreting our slope and our y-intercept. Sometimes our y-intercept is going to be meaningful, sometimes it's not. But we definitely want to talk about that slope and how that impacts our model. As far as our model, one of the main things that we're going to use to determine if our model has a good model fit or not is going to be our adjusted R-square. Remember, we use the adjusted R-square because that kind of compensates for the number of variables in our model. And the big thing we're getting at here is it's going to be the percentage of the variability in our dependent variable, whatever that is, that's explained by the relationship between our independent and dependent variables. So just kind of the big highlights from what we spent last week. We're going to have two different tests that we look at. We look at our F-test statistic, that tests for our overall significance. So overall is the model significant. Okay. Called an omnibus test. It's an overall test. So yes, do we have a statistically significant model? Great. Then we go down and look at our individual variables and say, are they significantly contributing to our model? And that's where our t-test comes in. Okay, so we look at both the F and the t-test. Remember that our focus on this class is all about explanation. Given the data that we have, what's the best model that will explain our existing data? So we care about the magnitudes of our coefficients, we care about the signs of our coefficients, we want to know what's happening. So this is where we left off. We say, great, if we have a continuous variable, we can predict another continuous variable. Not too hard. What we're moving into now is if we have a categorical variable, how do we use that to predict a continuous variable? So this is where our dummy coding came in. And last time we talked about type of customer, promotional versus regular. We can change promotional to equal 1, regular to equal 0. We have a series of 1s and 0s that really will capture if we have a promotional or regular customer. That's kind of where we end. A few more theory things. Then we started to, and I kind of alluded at the idea of, well, what if we have a categorical variable that has more than 2 options? So the example we're going to use today is going to be method of payment. Right? So maybe we think the method of payment is really going to impact how much people are spending. Right? So you guys kind of did that for your AMP sales. Right? We want to partner with American Express because people who use American Express are buying higher value tickets. Okay, so does the type of method of payment influence our net sales? So when we do this, we take if we have k levels, then we need k minus 1 dummy variables to do our coding. Because we have the condition, a full 0, 0, 0, 0 condition, will account for that last level. Give me an example. Right, so we talked about our type of customer, zeros and ones, gender, ones and zeros. Does it matter what's a zero and what's a one?
No.
Okay, so from a data entry perspective, it doesn't matter. From an interpretation perspective, do you think it matters? Yeah. Probably so. Okay, so from an interpretation perspective, it matters. So one of the things that when you do a regression, if you have categorical variables, that is essential that you do is make sure to know which one's zero and which one's one. Okay. All right. So here, I don't even have them sorted alphabetically. I don't know why I have them sorted the way I have them. Okay. But I just started out, and so my first dummy variable is going to be for Razor card in this example. My second dummy variable is MasterCard. So this would be, here I have method of payment 1, method of payment 2, method of payment 3, and I'll do this a little bit better on the other slide. Method of payment 4. So I have 4 dummy variables in my 5 categories. Whichever one's represented with a 1. So discover, in this case, is represented by all zeros. Everybody okay with this? So when I have my equation at the end, I'm going to talk about the slopes in relationship to the discover card. In relationship to all that 0, 0, 0. That's kind of like my control, if you want to think about it that way. So in this case, if I had to pick a control type of payment, which type of payment would you pick as a control? Discover, because it's the top one?
No.
American Express because it becomes first alphabetically?
Doesn't matter.
Discover because you're trying to discover something.
It doesn't matter, not necessarily. The only thing it's going to matter with, and I'll show you this example, is you're going to talk about all of these changes in relationship to a particular card. Right, so as you're trying to interpret the slope, for me, I like the idea of, that's why I had a little arrow there, of Razor card being my control group. So if I assume that everybody walking in the door is going to pay with a Razor card, and if they actually pay with the Discover card, then do they spend more or less? Or if they pay with a MasterCard, do they spend more or less than if they buy with my card? Right. So it doesn't matter, no. What about if we come down here to like gender? Does it matter if male's 1 or female's 0, or male's 0 and female's 1? But if we try to put it in the equation and we're going to start to interpret this coefficient, which one do you want to be 1 and which one do you want to be 0? You put some thought into this. We'll come back to it. Right? So does it matter? No. From a coding perspective. Does it matter from an interpretation perspective? Maybe. So the other thing we're going to do, once we get past the categorical variables, we're trying to select a best model. Yes?
So where are we not having 1, 2, 3, 4? Where are we having in 0, 0, 1?
Why are we not having 1, 2, 3? Ask me that differently.
For the categorical variables like Razor card, Master, Discovery, why is it not just coded as 1, 2, 3, 4?
Because if you code it as 1, 2, 3, 4, then you're leaving it as one variable, and SAS is going to see it as a continuous variable, and it's not going to know how to interpret the coefficients. That's a great question. Right? So the reason that we're turning it into this dummy variable is so that we'll know if this condition happened, then how does it influence our overall model. Right? So there's going to be some variables that it may make sense. Like if you were talking about a rating system, right? And so our categorical variable was excellent, good, or excellent, very good, good, fair, poor. Maybe we would want to assign a 1 through 5 to that. And then we could treat that categorical variable as a continuous variable and be a little bit more okay with that. Okay. But here, since there is absolutely no ranking, it's just a nominal variable, we do the dummy variable. That's a good question. So now, once we have this model, we'll do this example in a second. Did we do this slide already? I'm going to remind you just. Right, we're always going to be talking about selecting a best model. Okay. So we're looking for low overall p-values, high adjusted R-squared, the fewest variables that we can get, and the last thing, it has to make sense. So these are the 4 conditions as we're choosing models. These are the 4 conditions that we're going to use to help us select a best model. Now we can do this kind of by hand and by trial and error using our ISYS to help us do the calculations. Or there are actually about 5 or more different ways that ISYS, using statistical analysis, can try to find good variable selection models for us. So one of them is called the forward selection model. We start with no variables in our model, and we add in variables as we go along. So we start with an empty model, we add variables based on the specified F statistic, and we add them one by one. So basically we're looking for what has the lowest p-value out of all possible, and that's going to go into our model. And then we do it again. We add another one. Okay, is our overall p-value still low? Great, let's add another one. Let's add another one. We're going to keep adding variables until we have, until we no longer have a statistically significant model. Are you going to know all the details to this? No. Do I want you to know the big picture of this? Yes. So forward selection, you start with nothing and you add variables. Backward selection, the opposite way. You start with everything in the model and you kick things out. So here you start with a full model and you're going to remove the least significant variable, one by one. All right, kick one variable out, kick out another one, kick out another one. Stepwise variable selection actually lets you do both. You add and remove variables. So you start with an empty model, you add variables into your model, but there is a chance that if you add 2 variables that are too highly correlated that you haven't kicked out, or that have some type of relationship, you can take a variable out of your model and replace it with a better model, or replace it with a better variable. Right, so stepwise regression lets you do both coming in and going out. And if you had to pick, which one of these do you think would be the best?
Backward.
I gotta vote for backward. How do you think forward?
Say forward.
I gotta vote for forward. Anybody for stepwise?
Sure.
Sure! It depends. Come on, you know I love that answer. It does, it depends. There is no one is better than the other. A lot of times what will happen, a researcher or analyst will find the one they like the best, and they just kind of stick with it because they like the theory of it. Right? A lot of people do stepwise because they think, oh, if you add and remove, that's a great thing. Okay. I'm a fan of the backward, personally, just because I want, here's everything in my model that I want in my model, and now let's start kicking out things that aren't statistically significant. Any of them work. I have a cool little flowchart. You don't need to know them. There's kind of a picture of what's happening. Start with nothing, you end up with something. Start with everything, you end up with something. Here, you're putting things in, you're taking things out. Other options, you could actually try every possible subset. The more variables you have, the more computationally expensive this is. But you could actually look at every possible subset, and SAS will do this for you, and then rank them by the adjusted R-squared, or there's another metric called Malo-CP. There's a link if you want to learn more. I like adjusted R-squared for this one. And you can rank them and then try to decide, okay, here's the best subset that has the highest R-squared. Well, if I lose one more variable, my R-squared doesn't change that much. And you can start to kind of decide based on that. And I've got examples of all this here. So those are kind of the big key topics left in multiple regression and model selection. That's what we're going to focus on today. So let's focus. Let's do some examples. So, again, we're going to go back to our Razorback stores. We've already kind of asked the questions with the simple regression of, can the number of items purchased predict net sales? Yes. Right? Statistically significant, but not a huge R squared. Can age predict net sales? That was horrible. Can the previous total spend predict net sales?
Yes.
It did, but only for our loyalty customers. Right? So today we're going to kind of review our last multiple regression one. We're going to get into the categorical predictors with type of customer and method of payment. And then finally we'll wrap up today with trying to figure out which set of variables predicts net sales the best. So for this first one, I'm just going to use my slides, and we're actually going to get into SAS so you guys can do some practice. So for loyalty customers, can the number of items purchased, the customer age, and the previous amount spent predict net sales? So I put everything in my model. I have an output. It's lovely. We have an overall, we have a statistically significant model. I should draw on this. All right, so overall we have a statistically significant model. Right here. Is our model good? Are we explaining a lot of the variability? Yes, we are. But if we look at the individual items, I'm kind of small behind my head, we'll notice that our second, that's why I made it big over here, age isn't statistically significant, so we're going to get rid of age. Right, so this is how I'm choosing a best model. Right, I have a low overall p-value. I have a high adjusted R squared. Now I want to find a model that has the fewest variables possible.
And you're using adjusted R squared because there's multiple.
Yes.
Instead of just
Yes. Absolutely. Okay, so I'm going to get rid of age, because age isn't really, it's not significantly contributing to my model. Let's get rid of it and see what happens. I think we kind of did this at the end last time, right? We started kicking out variables. So here we got rid of age, and we find that we still have a statistically significant model. We're still explaining 81% of our variability, and now all of our variables are statistically significant. So we could stop right here. In fact, I did stop right here. You could go a step farther if you wanted to and take out another variable, but now it's going to be a little more, which variable are we going to take out? So from this output, it's a little bit harder to know that. So overall, what we've done is we have had that null hypothesis, that there's no linear relationship. Caveat here. This should actually be at least one slope isn't equal to 0. So either no linear relationship or a linear relationship exists. Our p-value is small. We reject our null, so there is a linear relationship between at least one of these items, or between at least one of these variables. We can go and look at these individually, and we'll find out that there's actually a linear relationship between both of them. Right. So you'll notice I go through these 6 steps, but we also did the same thing just kind of by looking at it and I was putting check marks by things. Right? So at this point in the game, you're not having to go through the 6 steps quite as intentionally as you had to at the beginning of the semester, right? And that's okay. Yes?
Is this also like taking into account maybe the relationship between items and previous spend? Like if there's anything...
Like an interaction?
Yeah.
Not today.
Okay, but that's...
Next week, yes it can. Yeah. So right now in my model, I'm just looking at the individual contributions by each variable.
Okay.
But could we improve our model and enhance our model? Right? So just like how we did a one-way ANOVA, and we didn't care about the interaction. And then we did a factorial ANOVA, and we cared about the interaction. We can do the same thing in regression.
Okay.
Yeah. Absolutely. Just not yet. We'll get there. So then based on our information, using our parameter estimates, we can create an equation. We can talk about if we hold previous spend constant, for every additional item, net sales is going to increase by $1.81. if we hold the number of items constant for every, and you can see I changed this a little bit, right? For every additional $100, net sales is going to increase by 724. Right? So when I'm explaining when I'm explaining this, I can make it where it makes more sense. Okay? So the 724 came if I would have had more decimal places. That's right here. So this is actually 0.0724. And so this is one of the things I noticed as I was grading some of your papers. Right? As you're telling your story, tell your story so that it makes sense to the reader. It doesn't have to be, oh, this is exactly what the question is asking for, whatever. Tell your story, write your digital story, write your executive summary so that it makes sense to the person reading it. Awesome. We've already talked about our R squared, so now we're going to move on. Questions about just general multiple regression, continuous versus continuous. Continuous predicting. Alright. So this is where we finished up last time. Can type of customer predict net sales? We had customer as regular as 0, promotional as 1. We looked at the scatter plot and was like, yeah, not so helpful. We got our equation though. So overall, if we look at our overall model, is it statistically significant? No. So really, if I was doing this, I would stop right there. Yes.
How is he adjusted?
That's a great question, right? You guys hear his question? How is he adjusted R squared negative? That's just weird. So in general, do what?
What does that mean?
What does it mean?
Yeah, if it's negative.
It means that there's absolutely no relationship whatsoever. So, in general, when we talk about correlation, our correlation, our R value, can go from -1 to +1. If it's 0, there's no relationship. The closer it is to 1, the stronger the relationship. Right? We're good with that. And -1 to +1 is our rule. When you look at your R squared value, it ranges from 0 to 1. 0. Just can't have negatives when you square it. 0 to 1. The adjusted R squared, though, takes into account the number of variables that are in your model, even when you just have one variable. And so if you actually go and look at the calculation, it's subtracting off a little bit for the number of variables, even if that number of variables is 1. So because our R squared value is practically 0, when you're subtracting from practically 0, you wind up with a negative value. But this doesn't happen a lot. Right? It's very rare you're going to see a negative R squared. It's very rare. You can see an R squared slightly over 1 as well. It doesn't happen a lot, but those do exist. This just happened to be a weird, and it's because there's absolutely no predictive relationship here at all. So kind of a fluke in the system, if you will.
So when do we use the adjusted R squared? When there are like 2 or more variables?
So you can use the adjusted R squared all the time. Like if you just want to default to the adjusted R squared so you don't have to remember when to do it, you can use the adjusted R squared all the time. You have to use it. Let me rephrase it. I strongly encourage you to use it when you have 2 or more variables. Alright. So that answers that question. Great question. Yes.
Just want to add that statisticians will make great politicians.
What?
How diplomatically correct you are saying it.
I mean, you gotta be careful with how you say things. You gotta be careful. I never say never. I say there's just a really, really tiny probability. Okay, so overall, not statistically significant. Not explaining anything. We're good there. So that's what we're saying here, right? P-value's bigger, we fail to reject, there's no relationship. However, because this is class, and I do want to talk about this, this is where we left off. We can still make an equation. Should we use this equation? No, but we can still make one. So our intercept is 157.15, and and we have $1 plus $1.91, and then we have our customer value. So if our promotional or customer type is promotional, that means X is 1. Then we plug a 1 in to this value, so 1 goes right here. And that's what I have down here at the bottom with the prediction. All right, so we have 157.15 plus $1.91. We end up with $159.06. If our customer type is 0, then that just cancels out, and we're just left with $157.15. So that slope is talking about I'd say our control group is just our regular customers. So that slope says that when our customer is promotional, we get to add $1.91. When we just have a regular customer come in, our intercept doesn't change. But what if, right, so we're not going to use this. But what if, we already talked about this, I change regular and promotional? I love it, right? That's my question. Well, what if you switch it around? Then what happens? Well, let's find out. So the p-value doesn't change. Still not a good model, right? So really an X there. The r-squared value doesn't change. It's still bad. But what does change are the parameter estimates. So now I have 159.05 minus $1.91. My slope didn't change. What changed? So my y-intercept changed, and the sign of my slope changed. The value for my slope didn't change, but the sign did. So when type of customer is promotional, now promotional is 0, so that says go away, so now net sales doesn't change. And when we're a regular customer, we're a 1 right there. So now we're going to decrease, so we have a negative sign now, by $1.91. So if I plug this in and actually do a prediction, I start with the 159.05. I subtract $1.91, now that's a promotional customer, and I end up with 159.05. In my other example, I ended up with 159.06. So there was a rounding error there, but your prediction is going to be the same, no matter how you set up your equation. The difference is that y-intercept changes, the sign of your slope changes, the way you interpret it changes just a little bit. Okay, so does it matter? No. But it does make a difference when you do your interpretation. Still not going to use that. All right. Moving on. Let's do some multiple stuff. So now we have a method of payment. So I actually have this set up, and it's written here, but I'm going to kind of make it organically too. So I have method of payment, and instead of doing 1, 2, 3, 4, I'm actually going to call this method of payment discover. And so discover is going to get a 1, and everything else is going to get a 0. And then I have method of payment MasterCard. MasterCard gets a 1, and everything else gets a 0. And method of payment Visa, and Visa gets a 1, and everything else gets a 0. Method of payment American Express, and American Express gets a 1, and everything else gets a 0. So I have 5 levels, which means I need 4 dummy variables, because this is method of payment razor card. We're not actually creating a method of payment razor card, but if everything is 0, then we're going to say that method of payment is our razor card method. Questions about this? A lot of the questions that you guys were posing had to do with, I want to do some type of regression using categorical variables. So you think you'll be able to do this for Okay. All right, so what did I do? Well, let's get into Enterprise Guide and do this. So if you guys want to follow along, you can. If you just want to watch and play, that's fine too. I always forget to pull this up ahead of time. So the data set we're going to be using is going to be Razorback Stores, 5503, and it's going to be the dummy data set. Dummy. Did I show you guys how to do predictions last time? There's enough? Yeah, I'm going to say even if I did, you don't remember it, so we'll do that again too. Okay.
So this is a dummy new.
No, dummy. Just dummy. Not the dummy new, just the dummy. Thank you for asking. Alright, so in lovely SAS Enterprise Guide,
Are we gonna be in the Razorback Stores?
Razorback Stores, dummy. So Razorback Stores 5503 underscore dummy. File, open, data. So in our shared data file, yes, it's the Razorback Scores 5503 underscore dummy. So not the dummy new, but the actual dummy data set itself. Alright, so if you scroll all the way over to the right, you'll see that I have created a whole bunch of dummy variables. Are you guys comfortable with the query builder to be able to create a dummy variable? Yeah. You need to see it?
Let's see for this.
Yeah, just want to do one real quick?
One is more than two.
Okay. So what we're doing here, so I sketched out what I want to have happen, right? So my method of payment underscore D, that's going to be my discover. My method of payment underscore MC, that's my MasterCard. Okay, so that's where these are coming from. So what I'll do is I'll use my query builder. I'm just going to add a new computed column. We'll say new. We're going to add a new computed column. I'm going to recode my column. Click next. I'm going to choose my variable that I'm interested in. So the variable I'm working with is method of payment. So I'm going to do new method of payment. I used a new one because we changed some issues in the other one. And I'm just going to do some replacing. So I'm going to add, well, first thing I'm going to do, hold on, let's take one step back. So basically what I'm doing is I'm taking this character variable and I'm turning it into a numeric variable, right? Because linear regression only works with numeric variables. So we're basically trying to trick the linear regression idea into saying, well, it's a categorical variable, but I'm going to make it a numerical variable so you can work with it. Okay, so I'm going to change this to numeric down here. So I'm going to do add. And so the first one I'm going to do is the discover. Okay, so I'm going to add discover. Click OK. And I'm going to replace this value with a 1. So here it's important that we do not enclose this value in quotes. Right? Because quotes makes it a character variable, no quotes makes it a numeric variable. So no quotes. I'm going to click OK. So discovers 1, so everything else is going to be a 0. So I'm going to add, and here I'm actually going to, let's see, I'm going to click American Express. I'm going to hold the control button down and click MasterCard, Razorcard, and Visa. So here I'm able to do 4 of these at once. So for all 4 of these options, I want it to be a 0. Click OK. So Discover's 1, American Express, and everything else is 0. It's what I want it to look like. I'm going to go to the next. And this column name that I'm going to give it will be method of payment underscore discover. Or you can just do underscore D, right? However you want to name it. You want to go down to the bottom, and here, the formatting right now, it's currently a character format, so we want to change that. And you can just change it to no formatting. SAS can handle it. Click OK. You could give it a label if you wanted to. We haven't really done much with labels. All the label is this could be like dummy method of payment discover. The longer your label, the more room it takes up on your output. That's why I don't do a lot of labels, right? But the label is going to be the part, if you try to make graphs out of things, it'll print the label. So if you want to make it look prettier, that's what the label is. So we're going to finish. You can click next and then finish. So everything should be good. If we close it and we did everything right, you can drag everything over. Keep all the variables. And then we can run this. So now here's my method of payment discover. It's right here. It's a bunch of zeros and ones. And if I look here, I have American Express, and I'm getting zeros. Over here, I've got Discover, and I've got a whole bunch of ones. Down at the very bottom, it says MasterCard, and I'm back to zeros. So you can kind of spot check it. Everything turned out well. So if you were creating this variable from scratch, you would then go in and create another variable that was method of payment American Express. And another one that was method of payment MasterCard. And another variable that was method. So you would have to create 4 variables. To save time, this is what's right here. Okay, so I've done it for us. Questions about this part?
Do you need to create one for the razor card?
You do not. Because that's going to be all of it. Everything's all 0, so right here, let's see if we can find a razor card. There's MasterCard, razor card. So for the razor card, you can see that all of these are 0. And so this is our control group. All right, so now let's do it. Let's go and analyze our data. We're doing a regression. We're going to do some linear regression. We're still trying to predict net sales. I'm going to go down here and grab new net sales. And now our explanatory variable, I've got to take all 4 of my newly created method of payments. So even though it's 1 variable, we've now made 1 variable into 4 variables. Right now for our model, we're going to leave the full model. For the statistics, we're going to leave that one blank. For the plots, we're not going to deal with anything there. We're just going to leave it for right now, and we'll get to it. Predictions, I'll show you how to do that in a minute. So right now, all we've done is basically put the data in, and we're good to go. So we're going to click Run. And it seems to be taking a little longer than it has in the past. And that's because of what the regression analysis is having to do. It's not just computing, or not just computing means, now it's actually trying to find those lines of least squares. We've got more variables, so it's a little more computationally heavy. All right, so first question. Overall p-value. Do we have a statistically significant model? Yes. Assuming a p-value of 0.05 or less, we have a statistically significant model. We can continue on. I'm going to skip the r-squared for a second. I'm going to go down to the parameter estimates. So now I'm going to go look at each of these variables individually. So for my method of payment discover, I have a p-value of 0.0081, so it's statistically significant. My MasterCard has a p-value of 0.92. That's not significant. My Visa's got a p-value of 0.43. That's not significant. My American Express has a p-value of 0.0447, less than 0.05. That one is statistically significant. Now what? We're trying to predict net sales. We have a y-intercept. Yes.
Could there ever be a case where the intercept wasn't significant?
No.
Okay.
Just the way the model's
Rather than
created.
magnified? Okay.
No, the way the model's created, the intercept should always be significant.
Okay.
So what comes next? What do I add to my model next? My variables, which one? Okay. So now I have minus 2075 x, and then if I could do method of payment discover. Which one next? American Express. Okay, so that would be plus 3079 x, method of payment American Express. Am I done? Do I add some more? What happens at this point?
What is the razor card? Or what?
So the razor card we get if everything's 0,
Right, okay.
then we get razor card.
Okay.
So would it just be the y-intercept?
So it's just the y-intercept, yeah.
Okay.
For this equation, please. Right, because it's our control group. So we're making the assumption that for razor card, all of these slopes, we're going to say, compared to the razor card, there is a $20 decrease when you use a Discover card. Compared to the razor card, there is a $30 increase if you use American Express. But it's got to be compared to something. So you can compare it to razor card, or in our first example when we had zeros everywhere for Discover, then we would be comparing it to Discover. So that's where it makes a difference. It's just an interpretation. So what about MasterCard and Visa? Do they go on our equation? How many say yes? How many say no? How many say, I'm not really sure right now? Seems like a trick question. Totally a trick question. So here's what you'll see on your slides. It's all or nothing. So this is the method of payment variable. Now we had to break it apart to make the linear regression work, but ultimately it is one variable, method of payment. So you either include the method of payment or you don't include the method of payment, but you can't pick and choose. Okay? This is like the hard piece to... SAS doesn't know the difference. It just sees it as a continuous variable and it just goes with it. But for us, we know the method of payment is one variable, and we either get it all or nothing. Okay? So, for this one, how might we decide? Do we want to use method of payment? Or do we want to try and find something different? Why might we want to find something different?
Yes.
So that r squared, that adjusted r squared, right? So yes, we have a significant model. So we have a low p-value. Our next thing that we look at is do we have a high adjusted R-squared? And no, we're not explaining any of the variability using method of payment. Okay. So all or nothing, we're going to pick nothing in this case. But if we did pick something, right, so here, this is just one variable, significant, there is a relationship. Let's talk about how we will interpret the coefficients. Right? So if our method of payment is discover, then discover's a 1, everything else is a 0. Right? So all of this goes away. And we say that there's a $20.74 decrease in net sales. And here I'll even be a little more specific. Compared to using a razor card. Okay. For the MasterCard, we would give MasterCard a 1, everything else gets a 0. So we keep this part, get rid of all the rest. There's a 40-cent decrease in net sales. For Visa, you got a $3.88 increase, and for American Express, a $30.79 increase, or $30.79 increase. But for Razor Card, so Razor Card, all of these are 0. So there's no change in net sales. Yes.
You could have probably done this, so we're not going to redo the whole thing. But supposing it discovers what we had chosen as the control group instead of razor card, then we would see that the difference would, instead of seeing this, most of these cases, the difference was like 0.4 and 3.88 increase. Whereas if discover was what we were using, then for razor card, that would have been $20 increase. For MasterCard and Visa card, it would have been 20 again and 23, and it would have been $50 for American Express. So I mean, these decrease or increase is going to be more significant than what we see now.
Yes.
So would that actually affect the R-square in any way, or but
No.
because the others are close to each other, it would?
It shouldn't affect the R-squared. So whatever you put as your control variable shouldn't affect the R-squared whatsoever, because the data is still the same. It does change the equation that you have to explain. Yes.
So why did we look at all the different variables to see if they were like statistically significant or not for doing like all of them, since they're all technically like this?
Great question. So for me, so we have an overall statistically significant model, right? But let's say that, so Discover is going to be really significant, but American Express, I mean, we're talking 0.044. That almost rounds up to 0.05, and if that's our cutoff, then that's almost not statistically significant. And then I would have 3 of my method of payments that are not significant, and only 1 that is. I probably want to keep this in my model, right? Now here I have 2 and 2. Maybe I want it in my model, maybe I don't. Let's go check out the adjusted R-squared. But if I have 3 of these, 3 out of the 4 that are significant, then maybe I do want to keep it.
Okay.
So this just kind of helps you decide, keep it in the model, don't keep it in the model.
Okay, that makes sense.
Yeah. Good question. Other questions?
This is something like the Simpsons paradox, right? How individually they had impact, but together they could have a different.
Yes. You think of it. I don't know that I've thought of it in that way, but it can kind of have that idea. It's not a completely a paradox because one of them will most likely be significant. But yeah, it's kind of like you're looking at the overall impact of the entire thing. All right. So then we explain things. I put it's green now. It's like, you could use it, but yeah. I still wouldn't, but you could. Alright, so the next question, we got about 10 minutes to kind of do this. Which set of variables are the best? Okay, so this is where we go back to our model. We're going to modify tasks. We're still trying to explain net sales. We found that previous sales worked, or previous amount spent worked really well, but that's only for the loyalty customers. And I want to be able to make a model for all of my customers. So I've got method of payment in here right now. Really what I'm going to do is I'm just going to look at any possible thing that I think could be a predictor variable, and I'm going to put it into my model. Okay. So the customer number, no. The type of customer, we know it's not, but we're going to do it just for illustration purposes. Right, so type of customer had to be a dummy variable. And I'm going to have, this is P1, so this means promotional is 1. So this is what I'm going to use. So my dummy customer, promotional 1. I'm going to throw that in my explanatory variables. Let's see, what else do I have? The number of items. I think I have a new items. So I'm going to throw the number of items in there. We're predicting net sales, so we shouldn't use that. Let's see what else is up here. Gross sales. Should we use gross sales to try to predict net sales? I mean, we could. But should we? Here, let's do it just for fun. Let's throw it in there. Gross sales. What else do we have? Method of payment, we already have that in there. We've got gender and marital status. So again, we can't say male and female, we have to say 1 or zeros. So I have a dummy gender and a dummy marital status. Males are going to equal 1, single is going to equal 1. And I chose males and singles to equal 1 because I went back and I looked at our data set. And do you remember, do we have more males or females that shop in our store?
Females.
Females. So I'm going to have the females going to be my control. And did I have more married people or single people in my store? There are more married. So I put married as my control and single as 1. It doesn't matter. It's all just about how I get to interpret things at the end. And so this is where you guys can all come up with a different equation based on how you dummy coded your variables and based on if you think about including or just not including other ones. All right. Do we have anything else we need to add in? So we want to know if they're a loyalty member or not? We can do that. Throw in loyalty member. I'm just throwing everything in. I'm going to leave out the past store visits and the previous stuff because that decreases our sample. Age. Throw in another continuous variable. I'll throw in age. We could put in day of purchase, but this is one of those problems we're going to run into, right? So day of purchase can be coded 1 through 7. But can we use 1 through 7 here? No. Because what happens if we plug in a 5? We have no idea if that's Friday or Tuesday, or I could code that however I wanted to. So if we wanted to do day of purchase, we'd actually have to dummy code day of purchase. And I didn't do that here. So we're going to not use that one. Alright, so I've got all my different variables in here. I'm going to run this and see what happens. You want to replace the results? Nah, give me something new. Everything's running. Look at us go. Shake it out. We've got a statistically significant model. We're explaining almost all 100% of the variability. Why is this happening? Should we really have gross sales in our model? No. Okay. So gross sales is in our model. It's statistically significant. All of this stuff up here is statistically significant. Down here, not so much. Okay. But really, gross sales shouldn't be in our model. So I'm going to go back. I'm going to modify my task. I'm going to take gross sales out of my model. Watch my R squared go down. I'm going to run this again. And I'm going to replace the results because those are bad results. Right? Didn't make sense. So how do things change? So, do we have a statistically significant overall model? Yes. Oh, what happened to our R squared?
Why did the significance of each variable change so much?
Because of the relationship between gross sales. So depending on what other variables you have in your model, the combination of variables in your model make a difference. Oh, it's fun. You'll play with this. It'll be a blast. So this one, so we're explaining 25% of the variability, 26%. Not a whole lot, not horrible. Not a whole lot of models, variables in here. So we can just look at this. So from this output, if we did this kind of like eyeballing it, customer, type of customer, not significant. Method of payment for our Discover card, significant. MasterCard, Visa, American Express. So now 3 out of 4 of my methods of payment aren't significant. Would you keep method of payment? Probably not. So we just lost method of payment. Items is still good. We're happy there. Gender is close. It's 0.06. It's not significant, but it's closer than some of the others. Marital status, not so much. Oh, if you're a loyalty member or not, that's something. And then age is not significant. So if you wanted to rerun this model, so here my R squared is 25.93%. Which variables would you keep?
150.
Which ones? I know it's teeny tiny.
New items and
There you go. So items and loyalty. Yeah. Okay. So I'm going to run this again. So I'm going to modify my task. I'm going to say type of customer didn't make it. Our methods of payment didn't make it. Oh, I'm going to regret this in a minute. So number of items gets to stay. Loyalty member gets to stay. Everything else is out. I'm going to run this again. Now my adjusted R squared is 25.33%. So I'm basically still explaining the same amount of variability. I have an overall statistically significant model. Both of the variables in my model, right, so I went from a whole bunch of variables to 2 variables, and they're statistically significant. I'm not explaining a lot of the variability, but I'm explaining some. So having the data that I have, this is probably one of my best models. Agreed? Yes.
should we still check out the interrelationship between items and loyalty members? They have a transaction.
Yeah, you could look at the correlation between the two, but since one is a categorical variable and one is a continuous variable, it's just a little bit more difficult to do. You can't just do like a correlation matrix. So yes, you could look and see, is there kind of like a random distribution of items between loyalty members and not loyalty members? You could. So this is kind of what we're going to come up with for a best model. So right now, over there. items and loyalty are kind of our top variables for our model. So now, the last couple minutes, let's let SAS come up with its best model. So I'm going to go back and modify task. And up to this point, we haven't really messed with the model at all. We've left it as full model fits, no selection. So unfortunately what I'm going to do is I'm actually going to go back and all those things we had in there for our explanatory variables, I'm going to add them back in. Right, so I'm going to add in marital status, I'm going to add in gender, I'm going to add in all the different types of methods of payment. I'm going to add in the type of customer. I'm going to add in age. And if you miss one, it's not that big of a deal right now. I'm going to go ahead and keep out gross sales so it doesn't do anything crazy for it. And then I'm going to go back to my model. And here's where you get to play. Forward selection. Or a run this. And what this provides is a step-by-step of, hey, what's happening. So forward selection. We entered new items. And this is what happened. And then in step 2, I entered loyalty member. And this is how your p-value changed. And in step 3, I entered method of payment discovered. You still have a significant model. And from step 4, I entered the dummy gender. Still significant here. All my variables are significant. Step 5, we entered visa. Oh, visa is not statistically significant, but overall our model is, so I'm going to keep it in. And you keep going all the way down to the bottom, step by step, and you get this summary of what happened. Here's the number of variables we put into our model, here's the model R squared, and here's the significance of our overall model. So it created, and it's going to say that these 9 variables make the best model. You can see you guys don't like that very much. So we could go back and we could try to modify task. Go to the model, and you could try backward elimination. So we start with all of the variables. All the variables. And start kicking things out. So here we started, here's the full model. Here I kicked out method of payment MasterCard. Here I kicked out marital status. I'm just kicking out the least significant variable. Here I kicked out type of customer, and you go all the way down to the bottom, and they're going to say that these 6 variables